All right, let's get right into it. We're going to be talking about a pretty big shift in how we think about building software. It's really about ditching that creative, but let's be honest, often chaotic process of just jumping in and coding. Instead, we're moving towards something way more structured, more intentional, and supercharged by AI. Basically, we're going from impulse to instruction. You know that feeling, right? An awesome idea pops into your head, you fire up your code editor, and you're just in the zone. You don't have a map, but the vibe feels right. You start hammering away, and pretty soon, you've built this thing. But you're also completely lost in a maze you created yourself.
Well, there's actually a name for this: vibe coding. It's when you build based on a feeling instead of a plan. And look, it can be amazing for banging out a quick prototype, but when you're building something serious, it often ends with code that's a total nightmare to maintain and doesn't even really do what you first imagined.
So here's our game plan. First, we're going to look at the vibe coding trap. Then we'll introduce a better way, a blueprint for your code. After that, we'll talk about a tool, GitHub Spec-Kit, that makes this practical. We'll get real about the pros and cons, and then we'll wrap up by looking at how all of this is changing what it even means to be a developer.
Okay, first up, let's really unpack the problems that come from just building on impulse. What actually happens when vibes are your foundation?
The fallout is not pretty. You get inconsistent quality because there's no single source of truth. Documentation? Yeah, that's usually an afterthought, if it happens at all. All of this just piles on the technical debt, slowing you down later. And the most painful part? All the rework. You waste so much time fixing things built on bad assumptions, and you end up with a product that's just a shadow of your original brilliant idea.
But there is a better way. Think of it like having a detailed architectural blueprint before you start building a house. It's a method that makes sure you build the right thing, the right way, from day one. And that brings us to Spec-Driven Development, or SDD. The idea is so simple, but it's a total game changer. You flip the entire process. Before you write a single line of code, you create a super detailed spec, a spec. This document becomes your North Star, your single source of truth. It forces you to think through the hard problems before you get bogged down in the code.
And this slide just lays it out perfectly. Look at the difference. Vibe coding is code first, which is basically guesswork. That ambiguity leads to rework. But spec-driven development, it's spec first, which gives you clarity and precision. You stop making vague suggestions and start giving clear, concrete instructions. The result? Total predictability. So, what exactly goes into a spec? Well, it's not just a couple of notes on a napkin. It's a full-blown plan. You start with the big why, the project's mission. Then you get into the what, all the functional requirements. You cover the how well, like performance and security, and you even map out the architecture, the tech stack, the data models, and the UI flows. It's the whole shebang.
Okay, this all sounds great in theory, right? But how do you actually do it without it being a huge pain? Well, that's where we go from the concept to a real-world tool that makes this all possible. Say hello to GitHub Spec-Kit. It's an open-source toolkit built to make STD a practical, repeatable process. And the best part? It's designed from the ground up to work with AI assistants like GitHub Copilot. It turns your AI from a clever guesser into a powerful builder that executes your vision perfectly. And the workflow it provides just makes so much sense. First, you write a constitution, your project's ground rules. Then you specify, describing the what and why. Next, you plan out the technical details. After that, you break that big plan into small, bite-sized tasks. And finally, the magic step. You implement by handing that beautiful, structured plan over to your AI assistant to do the heavy lifting. Now let's get real. No methodology is a magic wand. So it's time for a reality check. We need to look at both the incredible upside of SDD and the potential traps you need to avoid. First, the promise of productivity here is huge. I mean, look at this. GitHub's research found that when developers use AI with a structured workflow like this, they can finish their tasks up to 55% faster. That is a massive speed boost. It frees you up to stop worrying about boilerplate and start focusing on the high-level problems that humans are best at solving. So you've got to weigh the trade-offs. On one hand, the advantages are amazing. Everyone's aligned, your productivity skyrockets, and your spec becomes living documentation. But on the other hand, the challenges are very real. It takes time to write a good spec. A bad one will get you bad code, just faster.
and you have to be careful not to over-rely on the AI and let your own coding skills get rusty.
And this quote just hits the nail on the head. Garbage in, garbage out is on steroids with AI. A vague spec won't make an AI pause and ask questions. No, it will confidently and beautifully generate exactly what you asked for, which is perfectly wrong. The quality of your input is everything.
So, what does this all mean for the big picture? This isn't just about a new process. We're talking about a fundamental redefinition of what a developer is in the age of AI. We're moving away from the idea of a developer as a bricklayer, meticulously placing one line of code after another. The new role is so much more strategic. You become the architect who designs the entire structure and the conductor who directs a whole orchestra of AI agents to bring your masterpiece to life. Your job moves from implementation to intent. This really gets to the heart of it all. At the end of the day, just typing code was never the real job. True engineering is about understanding human problems and designing elegant, precise software solutions for them. And this new way of working brings us so much closer to that core mission. And that really leaves us with one last big question to think about. As AI takes over more and more of the actual writing code part, we all have to ask ourselves, is our real job to write code, or is it to solve problems? Because how you answer that question is going to define the entire future of this craft.